Example 6.2. Some doctors believe that a person can lose 5 pounds on average in a month by reducing his or her fat intake and by exercising consistently. Suppose weight loss has a normal distribution. So the problem statement is saying that weight loss is approximately a normal distribution, so N stands for normal, with mean 5 and standard deviation 2. So terminology, this is mean, and we denote it by mu. You read it as mu, and it denotes the mean. 2 stand for sigma, okay? This symbol, or you can think of it as you draw a circle but put a little hat on top. It's read as sigma, and it stands for the standard deviation, and we usually write it shorthanded as standard STD deviation DEV. Okay, so these are the terminology in this problem, and trying to pay attention is about weight lost. So if we lost 5 pounds, it's not -5, it's positive, okay, because we're tracking how many pounds is lost. And if we gain 3 pounds, it's not +3, it's actually -3, because again we're tracking weight loss. So in A, we need to find a z-score for a data point that equals 10. What it means is if a person lost 10 pounds, what is a z-score and what does it mean? So we use a formula, z equals x subtract mu divided by sigma. Now what it means is that the data point x, what we have is 10. We subtract the average or the mean, right? So that is mu. We have to look at our notation right here to find it, and that number is 5. And divided by sigma, sigma is the standard deviation, so it's right here is 2. So it's very important we learn how to put value into the appropriate place. And then you have to use a calculator or do it step by step. That's no rush, okay? 10 subtract 5 is 5. Then you divide it by 2, so you get 2.5. So if you're inputting that into your calculator, make sure you do it as open parenthesis, 10 subtract 5, close parenthesis, divided by 2. Then you should be able to get the correct answer, 2.5. What it means is, okay, so x equals 10 is, and what you put here is a z-score, 2.5 standard deviation to the, now is it to the left or to the right of the mean? And the mean here is 5. We know that. So how do we know? Is it to the left or to the right? You draw a picture. We know the mean, so what is in the middle is 5. And 10 is bigger than 5, so it's right here, and it's to the right of 5. So because 10 is bigger than 5, and the z-score is positive, it's to the right. Okay, so it's to the right of the mean. So on the other hand, in part B, where we talk about what is the z-score for gaining 3 pounds. Okay, gaining 3 pounds, you denote it by subtract -3 because you're gaining. And again, we're tracking weight loss. So in that case, we call the formula again, z equals x minus mu, same formula, but just different numbers for x. So what is x in this case is -3. Now you still subtract the same mean because we're talking about the same distribution, and you divide it by 2 as a standard deviation sigma, and make sure you use a calculator. It's -8 divided by 2, so the z-score is -4. Now when you have a negative z-score, okay, what it means is that value is below the mean. So underperformance, you can think about that way. So x equals -3 is -4, or you can even say 4 standard deviation, because if you're talking about the location, you already account for the negative. So it's 4 standard deviation to the, okay, negative, so you say left of the mean phi. So that's how we solve example 6.2.